Alright, welcome back, class. We're going to talk about the ionic bonding crisscross method. And let's just talk about the few things that we have up here for questions, and then we'll talk about how to do the crisscross method down here. So, let's first answer these questions up top. Ionic bonds form between a metal and a non-metal, right? We have a sodium metal here to a non-metal chlorine here, and that's how an ionic bond is formed. Ionic bonds are caused by the fact that opposite charges attract. So again, we can see that sodium is going to lose that electron, give it to chlorine. That becomes a positive sodium and a negative chlorine. That negative and positive charges, they cause them to attract each other. Now, what is the purpose of the subscripts in the compound? Well, if we have any number down here, that's called a subscript, and they just tell us how many atoms we have of what we have in that compound, right? If I had 2 sodiums for every 1 chlorine, it would be Na2Cl, right? That 2 tells me I have 2 sodiums working with 1 chlorine. However, as we all know, it's Na1 to 1 Cl, right? Which element is always written first in an ionic compound? Well, we can see that every time we always start with a metal, right? Metals go first because we keep it as that name, like sodium. And then nonmetal comes after, chloride, sodium chloride. When writing the names of ionic compounds, the ending of the metal stays the same, right? We call it sodium. And the ending of the nonmetal is changed to IDE, right? Best example, sodium chloride, right? All right. So, let's talk about the crisscross method down below. Got to go through a few things, and then we give it the formula and name at the end, and then this crisscross method is shown right here. Let's first go through the idea of how we got to find for valence electrons, what ion is created, and let's continue. So magnesium, if we find magnesium in the periodic table, it's in group 2, right? Right here, magnesium, group 2. That tells me I have 2 valence electrons, right? Don't forget, metals lose electrons. If it loses electrons, it gains a positive charge. So it's going to be Mg plus 2. Bromine. Bromine is located right over here in group 7. So how many valence electrons does it have? Well, that group number, right? It has 7. But it needs 1 more electron to get to 8, right? And so in this case, if it needs just 1 more electron, gaining that electron will make it a negative charge, Br minus 1. Now, here's how the crisscross method will work. I'm going to write both of these ions here, Mg plus 2 and Br minus 1. What's going to happen is that we simply criss and cross, right? The numbers. We don't cross the charges, we cross the numbers. So what's going to happen is that 2 is going to go right down here, and that 1 is going to go right down here. And our formula is going to be Mg Br2. Because that 2 went down over here as a subscript, and that 1 went down here as a subscript. And so our answer is going to be Mg Br2. The name, we keep the metal the same name, but this non-metal becomes the IDE ending, magnesium bromide. Hopefully that makes sense. Let's do one more. Let's see what we have here. Barium and neon. Barium and neon. Let's do that one. That one's interesting. These other ones you guys can do if you look at this example up here. But let's do this one down below. This one seems a little abstract, right? So we have barium and neon. Barium, if we find barium, barium's right going to be down here, way down below, right? But it's in group 2. So in this case, it has 2 valence electrons. And its charge, Ba plus 2. Neon. Neon, where's neon? Right over here, right? Neon has 8 valence electrons. It's in group 8, right? So it has 8. And for charge though, right, the charge for the ion, there is no ion, right? Every atom wants to get to a noble gas. And if we're at a noble gas already, well, it's not going to react. And so there is no reaction here. There is no formula here. And there is no name here. So what's going to happen is that this crisscross method doesn't work because there is no charge for neon. And barium's just going to sit by itself. It's not going to work. However, for every other one up here, we see that we don't have a noble gas, right? So you got to follow the same process. Find the charge, look at the valence electrons, find the charge, do the crisscross method, right? You just cross the numbers down, leave the charges up. You'll find your answer, and then now you have the name of the formula. Now, this one seems the same process, but we're kind of like simplifying it down to a basic thing here. Let's do this one here, strontium oxide. So oxygen, right? Oxygen turns into oxide. We kind of have to find that name, right? So the IDE ending, find that base word, right? Ox, and then fit it to something here, right? Oxygen, right? So oxygen is going to have a -2 charge. Reason why, again, is because it's in group 6 and it needs 2 more electrons, right? Getting 2 more electrons gives us a -2 charge. Strontium is way over here, right? Group 2. Again, group 2 is going to lose those 2 electrons and it's going to have a positive charge. Now, we can do the crisscross method. We can cross the numbers down, leave the charges up, and we find we're at Sr2O2. Now, can we simplify this? Is there any way we can simplify this? Well, if we can factor it down, right, if we can simplify it, we would find that we are at SRO. Because Sr2O2 means we have 2 strontiums for every 2 oxygens. Well, it's the same thing as having 1 strontium for every 1 oxygen. Because in reality, this +2 and -2 are already canceling each other due to the difference in the charges, right? +2 -2 equals 0. And so I don't need those extra 2's there. I can just make it like this. And that's going to be my answer here. Let's do another one here. Let's do this one, aluminum fluoride. Again, aluminum is in group 3. So it has 3 valence electrons. As a metal, it's going to lose them, so it's going to be positive, +3. Now fluorine is in group 7, right over here. It needs 1 more electron to get to 8, right? Getting 1 more electron means it's going to be -1. Criss and cross those numbers. 3 goes down, 1 goes down. You'll find that our answer is going to be Al F subscript 3. So that means I need 3 fluorines for every 1 aluminum, so the charges are equaled out. They cancel out, basically. And so that's the reason why we do these crisscross method, is we have to cancel out the charges. All right, what else do we got here? Write the names for the following ionic compounds. I believe everyone has the capacity to do that. Some things like this, you may have to kind of look at your gold sheet. Your gold sheet has a lot of things called complex ions or polyatomic ions. And so things like this whole thing here, this whole compound here, the ones I'm underlining, they are considered a polyatomic ion. And so they have their own name. Sodium with this, right? Magnesium with that. Calcium with this. Potassium with that. And so you keep it as the metal name, but this one is going to have its own name to work with. For an example, this one here would be sodium, and NO3, this whole molecule here, NO3, represents nitrate. Sodium nitrate. That would be your answer. Hopefully this makes sense for you. This is going to be my last video in the series for Monday, just for a quick review on what's going to happen. Again, I'm going to probably have, oh, where's my Schoology up? I got to put up Schoology, wow. my hope for you today is to complete everything in this folder that I have for you. Now, this Stable Atoms podcast will be optional for you to watch. It's more, again, review and note-taking, so those that weren't there on Wednesday, Thursday, and Friday for note-taking is going to help you out, basically. Alrighty. Well, you have a nice day, and I'll see you on Wednesday.